Hello and welcome to another lecture about data structure. Today we will discuss graph theory. First, what is exactly a vertex? A vertex or node is the fundamental unit of a graph as well as edge. However, edges are responsible to connect these vertices. So now what is a graph? A graph is a nonlinear data structure that consists of a set of vertices and edges. And as you can see, set of vertices are connected via edges. Now let's discuss type of graphs. The first is undirected graph, a set of vertices and edges in which the edges have no orientation. So it means that AB is identical to BA, and it doesn't matter whether we call it AB or BA. The next one is directed graph. Directed graph is a graph in which the edges have orientation. So AB is not identical to BA. For example, there's only one path from A to B, but there isn't any path from B to A. And this is the same for example, A to C. For the next vertex, which is B, there is no path to its adjacent vertices. And for D, there is only two paths from D to B and D to C. For E, there is only one path to D. And finally, for C, there's no path to its adjacent vertices. The next type is weighted graph, and in this type, every single edge is associated with a value in the graph. The next one is directed acyclic graph, that is a directed graph but with no cycle in the graph. Cycle is a path that the starting vertex and ending vertex is the same. Let's have a closer look into another example. Suppose we're given this graph. If we can find a path that the first vertex and the last vertex are the same, then we can say that there is a cycle in our graph. Let's start from A and then it points to the B. And from B, let's go to the C and then C points to the A. Because the first node has reached again, then we say there is a cycle in graph. The next type is multigraph. A multigraph is an undirected graph in which multiple edges or loops are allowed. So what is exactly a multiple edge? A multiple edge or parallel edges are two or more edges that connect the same two vertices. In this example, vertex A and vertex C are connected with two edges. So there's also a loop in our illustration. A loop is an edge that connects a vertex to itself, just as is observed for vertex B. The next one is simple graph. So a simple graph is a kind of undirected graph in which multiple edges and loops are not allowed. The next type is connected graph. In a connected graph, there is a path between every pair of vertices. So it means that, for example, let's to see if there is a path between B and other vertices. As is observed, there is a path from B to A and from B to D. And also there is a path from B to E that goes from D. And a path from B to C, which goes from D or A. In a nutshell, there is a path from B to every other vertex, whether direct pass or indirect pass. So if all other vertices satisfy this condition, then we can say that the graph is connected. And in this case, because there is a path from every vertex to every other vertex, then we can say this graph is connected. The next one is completed graph. In connected graph, we talked about path between every pair of vertices, but here in completed graph, we will discuss edge between every pair of vertices. It means there is an edge from every vertex to every other vertex. This graph is not completed, but let's to see if it was completed. Let's start from vertex E, then we must have edges to other vertices. If we want to have a complete graph, we must check each vertex, then create an edge between other vertices as is shown. Do the same process for other vertices in order to have a completed graph. This is completely different from having a path and having an edge. In a connected graph, there is a path from every vertex to every other vertex, but in a completed graph, we must consider an edge between every vertex to every other vertex. Now the graph is completed. Thanks for watching this video.